In this lesson, we're going to continue to add to our generic list class and then demonstrate how it can work with multiple data types. So let's open up the class definition again. That's in list.java. And what we want to do is add a method so that we can add data to the list. We're going to call that method add. And then we're going to write a toString method to display the elements of the list. We're going to postpone any further development of the class to the exercises for this chapter. So our add method is a void method, and here again is where we need to use our placeholder for our data type, because we don't know, as we're defining this class, what data type is going to be used, so we use the placeholder t instead. The code, we simply add the element to the current position in the list or in the array data store, and then we increment position by 1 to be prepared for the next add. And that's all we have to do. Again, the key is the fact that we're using our placeholder t for the data type, since we do not know right now, as we're defining the class, what the data type is going to be. And finally, we're going to override the toString method. What we'll do is we'll build up a list of elements as a string by looping through the array. And then adding each element as we come across it to the string. And we'll put an extra space in between each element also. Then when we're finished, we'll return elements. And that's all we have to do. So let's exit and save. And let's compile the class. And it works. Now let's write a program to test the class. So we'll call this program list driver, because it's a driver for the list class. We have public class list driver. The first thing we're going to do is create a list of strings. We're going to create a grocery list, so we'll call it glist, and we'll call the constructor and say 10 items to the list. So the 10 is passing in the number of items we want in the list, although we're not going to add that many. And let's just put a couple in there. We'll do milk and eggs. That's good enough. Then let's display the list, like so. Let's close off the program. Let's compile it and run it. It compiles just fine. And then we run it, and there's our grocery list. So let's go back into the program, and let's add a new list to demonstrate the generic capability of our class. And let's create a list of numbers. This time we'll just make it 5, although we're not going to add 5. We'll do 3. And we'll just do 3 simple numbers. And then we'll display our list. Just like so. Save the file. Let's clear the screen. Recompile it. And then run it. And there is our grocery list, originally milk and eggs, and our list of numbers 1, 2, 3. So looking at the code again for the list class, bring it back up. We are able to make our class generic by putting a data type placeholder in the heading of the class definition. And then every time we need to refer to a data type, we simply use t. So in the declaration of the data store array, we use t. In the actual initialization of the array, then when we're adding elements of that type, we also use t there as a placeholder for the data type. Then when we want to actually use the class, we substitute t with an actual data type. So here we have string. Right here we also have string. Then for our numbers, we have integer, and we have integer. Now, notice that when we're working with generic classes, or with generic methods also, which we'll see later in the chapter, we have to use the object data type and not the primitive data type. So rather than lowercase int, we have to use uppercase integer. And with string, it's the same for both, so it doesn't really matter. So that's how we create and use generic classes. And now we're ready to move on to the next lesson, where we're going to talk about creating generic interfaces that can then be used to create generic classes.